Hey everybody, I'm going to do a really quick video, try and sneak this in between my classes and review the homework problem number 3 for chapter 7, where it asks you to calculate average cost, average variable cost, marginal cost, fixed cost, and then graph them. There's a couple of different versions of it, so I'm going to do the one that came up for me, and like I said, I'm going to try and go quickly and use the dot cam to show you how to solve these problems. Hope it helps. All right, let's go. Okay, so this problem starts with us getting a cost function. The cost function is some version of this. So a constant plus q squared. And then we have to find fixed cost, variable cost, average fixed cost, basically all the different cost curves. So I'm going to just write them out here. So fixed cost, variable cost, total cost, and then average fixed cost, average variable cost, and then average total cost, and then of course marginal cost. And for these, it's pretty straightforward if you remember the definitions. If you're not super comfortable with them, you'll want to review that. Let me zoom in a little bit here so you can see a little bit closer. The tricky thing here is the exponential, right? We have to solve that. But let's go through and just break it down. So the first thing we want to remember is that this is our fixed cost portion. This here is our variable cost portion. And so what we'll be doing is breaking that down first here and then putting them back together for the total cost, which is already given, and then averaging, dividing by Q for all of our averages. So fixed cost is going to be $6. Variable cost is Q squared. Total cost is 6 plus Q squared. So far, so good. For average cost, we want to take our fixed cost and divide it by Q. So our average fixed cost is going to be 6 divided by Q. Our average variable cost is going to be Q squared divided by Q, which is actually just Q. And then our average cost is going to be 6 divided by Q plus Q. So remember, you can get average cost by either taking that cost function and dividing both sides by Q to get 6 divided by Q plus Q, or you can add up average fixed cost plus average variable cost to get average cost. So it's going to be 6 divided by Q, I regret putting these so close together, plus Q. The tricky one is going to be marginal cost. Remember, marginal cost is each additional unit. So what we can think about it is it's the change in either variable cost or total cost divided by the change in quantity. And the tricky part here is that it asks you to get a partial derivative, because really if we want to find marginal cost, it's the partial derivative of the cost curve with respect to quantity. I didn't realize this was in here, so I apologize to y'all. That's why I want to make sure I get this video out. So when we take that partial derivative, what we're going to do is we have our equation here, 6 plus 2q, and we're going to go ahead and let me grab a pen to kind of show this relationship. We're going to cancel out any constants that don't have a q associated with it. And then for anything that has the q, we're going to take the exponent down in front and reduce it by 1. So what that's going to give us is the partial derivative of our cost curve with respect to q is equal to 2q, because we've taken that exponent down and put it in front, and then we've reduced the exponent for q from 2 to 1. So now that gives us our marginal cost, which is just 2q. So that's the first part. The second part is to go ahead and graph those cost curves in that framework. All right, so we've got our q, and we've got our price, our costs. And what it's asking for is average fixed costs at q equal to 1, q equal to 2, and q equal to 3, and then also average variable cost and average total cost. 2, 4, 6. The nice thing is that at least the computer problems have really nice clean graphs for you. So I'm going to start with the average fixed costs. When I find a pen. So average fixed cost is going to be that 6 divided by Q. So it's going to be 6 divided by 1 for a quantity of 1 is just 6. 6 divided by 2 for a quantity of 2, that's going to be 3. And 6 divided by 3 for a quantity of 3, which is going to be 2. So that gives me my average fixed cost curve. Next is my, running out of space there. There we go. My average variable cost curve, which remember is just Q, right? Q squared divided by Q is Q. So my variable cost at a quantity of 1 is 1. At a quantity of 2, it's 2. And at a quantity of 3, it's 3. That's my average variable cost curve. And then last but certainly not least is my average total cost curve. I'm going to put that over here so you guys can see it. And the average total cost curve is going to be 6 divided by Q plus Q. So for a quantity of 1, 6 divided by 1 is 6 plus 6. That's going to start me off all the way up here at 7. For a quantity of 2, 6 divided by 2 is 3 plus, that's not right. Do-over. I'm not going to do a do-over because I'm running out of time. So assume I did it right. So now we have average cost. Let's say average cost at a quantity of 1 is going to be 6 divided by 1 plus 1 is still that 7. I had it right, I just didn't say it right. Average cost at a quantity of 2 is going to be 6 divided by 2 plus 2, which is 3, 4, 5. And then average cost at a quantity of 3, I know I'm running out of space here and time, is going to be 6 divided by 3 plus 3, which is 2 plus 3 is also 5. So I'll graph that up here, 7, and then 5 and 5. And so that would give us our cost curves. And we can see here the average variable cost and average total cost curves have the same general shape, getting closer together as average fixed costs are falling. Hopefully that helps. I'll get that posted. If you have other questions, let me know. And I will be doing another video shortly that looks at solving an isocost, isoquant problem for you. Okay, thanks so much. Have a great day.